All right, hopefully that was enough time for you to copy it down. So we're going to graph exponential functions. Our test is Tuesday. Did everybody get the quiz review? Is there anybody who did not get it from yesterday? And I'll post the answer key today. Okay. So when we graph an exponential function, that's just graphing a function that has an exponent that has a variable in it. So a couple of things to keep in mind. Who remembers AH and K from Algebra 2? Okay, so the base, if this number is a whole number or a number greater than 1, so if B is 2, 3, 4, 5, any number greater than 1, if the base is greater than 1, then we're going to use these numbers for X. But if the base is a number between 0 and 1, then we're going to use these numbers for X. The domain for every exponential function is all real numbers. The range is going to change. It could either be k to infinity or negative infinity to k. So if it's, what you can write is that if a is negative, then it's going to reflect down. And this is going to be our range. It's going to start at negative infinity and go to k. But if a is positive, then it's k to infinity. All right, we have this invisible asymptote going back to our rational functions. Remember, our rational functions had vertical and horizontal asymptotes. Exponential functions always have a horizontal one, and it's at y equals k. When we apply our transformations, we always add the h to x, and then it's y times a plus k. So this is just some of the rules to help us. Now let's go ahead and graph a couple, and we'll be finished. So I'll give you a second to copy that down. We're going to graph 2 to the power of x plus 1 minus 4. And because this number, this is my base, because that number is greater than 1, this is an exponential growth. This is exponential growth. Because our base is greater than 1. So our first step is going to be to make our parent table. And our parent table is just y equals 2 to the power of x. So we're going to ignore for a minute. We're going to ignore the h value and the k value. And remember that if it's growth, these are the x values that we're going to use. So we're going to use negative 1, 0, 1, 2, and 3 because it's a growth equation. That is our numbers we're going to use in our table. So we want to use numbers that are more on the positive side of x. All right, if you need a calculator, if not, you shouldn't need a calculator, but if you need a calculator, go ahead and use it. Find your y values. So you're figuring out what 2 to the power of, remember, these are exponents. So 2 to the power of negative 1, 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3. This x, let me go ahead and rewrite that because that looks like 2 times x. And I want to make sure you all realize that this is an exponent. That's an exponent. All right, go ahead and find those 5 y values. Okay, so 2 to the power of -1 is what? Who knows what that is? It's not 1/4. It's 1/2. It's 1/2. So I'm going to write it as a decimal because I know we don't really like fractions. Anything to the power of 0 is what? No, it's not 0. 1. 2 to the power of 1. 2 to the first is what? 2. What about 2 to the power of 2? 4. 2 to the power of 3? 8. All right, so this is our parent table. So now we're ready to apply our transformation. So let's go ahead and look at this function. The a value is the number in front of the base. So in this example, a is actually 1. There's an invisible 1 right there. So in this example, a is 1. H is always in the exponent, but you have to flip the sign. So H is not +1. H is what? -1. K, this is your K value, is -4. In your textbook for your homework, for some reason, sometimes they put this number first. So in your homework, it might say -4 plus 2 to the power of x plus 1. So it's the same thing though. So just know that. All right, so now let's do our transformations. Whenever you apply your transformations, it's always h plus x, y times a plus k. So I'm going to take these numbers and I'm going to add the h to x. H is -1. So let's go ahead and add -1 all the way down. And then your y side, your y variable, you're multiplying by a and adding k. So you're multiplying by 1 and adding -4. So go ahead and take a moment, create your new table. And this is the table that we're going to graph. So if you take -1 plus -1, -1 plus 0, -1 plus 1, -1 plus 2, -1 plus 3, get your new x values. For your y values, you're multiplying by 1 and then subtracting 4 to get your y values. And then go ahead and graph it. Now, before you graph it, let's go ahead and put in our horizontal asymptote. So what is our k value? What is k? So I want you to draw in your horizontal asymptote at y equals -4. So at y equals -4, this is the invisible line in the graph that it's not going to cross. So you want to go ahead and draw that in as a reminder that your graph should not go below that. So now we're ready to plot our points. So -2, -3.5, -1, -3, 0, -2, 1, 0, and 2, 4. So it's growing. Then it does not go. It's gonna just look like it's rolling on that asymptote. It does not go below it. And you could tell it's growth because when you trace the graph, it's growing. When you trace it from left to right, it's getting bigger. So this is growth. Now your domain, go ahead and make some space. All exponential functions have the same domain. So let me write it out here. So because you're going to have to tell me the horizontal asymptote, which is y equals -4. Is this graph increasing or decreasing from left to right? It's growth, so that means it's doing what? Increasing. That's also on the quiz, and I believe it's on your. So this is an increasing graph. Your domain, all exponential functions have the same domain, so that should be that point we should all get next week, because it's all real numbers. And then your range, because we have this horizontal asymptote, all of your y values are greater than -4. Now it's really important that you notice that in our range we do not have a bracket. There is no bracket, okay? And the reason why it's not a bracket is because it's never going to equal -4. It'll be -3.999999, but it'll never be -4, okay? So our range is parentheses -4 to infinity. And that is our exponential graph. Any questions? Let's do another one. I think I want to switch this a little bit, only because this still has an a value of 1, and I want you to have an a value. So let's change this to 3. No, let's change this to... Exponential functions are kind of hard because the y values get big so fast. So we're going to change it to that. So I'm going to make that a 3 times 2 to the power of x plus 3. So we have a base of 2 again. So our base is 2. So we already have our parent table, so I'm using these same values again. So let's make our chart for y equals 2 to the power of x. So what's going to change is our transformations. So we have our a value, our h, and our k. So what's the a value in this question? A is 3. What about h? -3. And what about k? -5. All right, so now you're ready to do your transformations, which is h plus x. So that'll be a -3 plus, go ahead and find your new x values. And then your y values, you're multiplying by a and adding k. So you're multiplying them by 3, and then you're adding a -5. So I'll give you a second to get your new table and graph it. Yeah, they get big fast. So we may not be able to fit. That's the bad thing about exponential. You may not get 5 points on there. So we just fit what we can fit. That's okay. Okay, so it's 1.5 minus 5. So is that negative 3 point? No, that don't seem. Is that negative 3.5? 3 minus 5 is negative 2. 6 minus 5 is 1. 12 minus 5 is 7. And 24 minus 5 is 19. So you might want to make sure those are right because I'm using mental math and that's never good in the morning. Plus I've given up coffee, so just make sure those are the right answers. Is that what you all got? All right, so where's the horizontal asymptote for this graph? Y equals negative 5, so we have a horizontal asymptote. I'm gonna write this at the top. Horizontal asymptote is at y equals negative 5. So I'm gonna draw that in. And then graph the points that will fit. So 4 down 3.5. Oh wait, that's the wrong spot. 1, 2, 3.5. Negative 3 down 2. Negative 2 up 1. Negative 1 up 7, and we won't worry about that last point. You can kind of see how this one is stretched. It looks stretched because A is 3. So your domain is all real numbers. This is again an increasing graph. This is increasing. Your domain is all real numbers. And your range is k to infinity, which would be negative 5 to infinity. Who had that for their example? Good. All right, we got a couple more and then we're done with everything that's on the quiz. So now we're changing the base to a fraction or a number between 0 and 1. So because 1/2 is between 0 and 1, your base is between 0 and 1. This is decay, which means this graph is going to decrease. It's not an increasing graph, it's a decreasing graph. Okay, so because it's decreasing graph, it's a decreasing graph. That means that you're going to have bigger numbers when the domain is negative. So to avoid trying to graph a lot of decimals or fractions, now we're going to use these numbers. So for our x values, we're going to use negative 3, negative 2, negative 1, 0, and 1 because this is decay. So for our parent, the parent is just y equals 1/2 to the power of x. So let's go ahead and figure out the parent table. So you're going to take 1/2 to the power of -3. And then 1/2 to the power of -2. And 1/2 to the power of -1. So what do you get when you type in 1/2 to the power of -3? You should get 8. Who got 8? And then you take 1/2 to the power of -2. You should get 4. 1/2 to the power of -1 is 2. Wait. Is that right? Yes. And 1/2 to the power of 0. Anything to the power of 0 is 1. And then 1/2 to the power of 1 is 1/2. Or 0.5. I'll put it as a decimal. All right, so now let's apply our transformation. So the number in front is a 1. So that means that A is 1. What is H in this example? +2. And what's K? -3. All right, so go ahead and apply your transformations. You're going to add the 2. And then for your y variables, you're going to multiply them by 1 and then add -3. So we got 2 to the power of, 2 plus -3 is -1, 0, 1, 2, 3. And then we have 5, 1, -1, -2, -2.5. So drawing your horizontal asymptote, you have a horizontal asymptote at y equals -3, and this graph is decreasing. So I always draw in my asymptote just as a reminder. And let's go ahead and plot our points. Now when you're looking at it, notice your y values are getting smaller from left to right. That's why this is decreasing. So your domain is still all real numbers. And your range, because A is still positive, so we haven't done one where A is negative, but because A is still positive, it is K to infinity, which is -3 to infinity. All right, we got one more, and we are done. So this is decay again because 1/3 is less than 1. 1/3 is less than 1. So this is a decay graph. So this is going to look like our last graph where it's going to start high and then go low, because the base is a number less than 1. So we're still going to use, we're going to graph, let's make our chart for y equals 1/3 to the power of x. And because it's decay, we're going to use the same x values. So now you're going to take 1/3 to the power of -3, 1/3 to the power of -2, 1/3 to the power of -1. So go ahead and fill in your chart. So your first number is pretty high, so we probably won't graph that one because 27 is kind of big. So A is 1. Sorry, not A is, no. A is -1. H is what? +1. And K is -5. So you're going to go ahead and apply your transformations, add the 1 all the way down, and then on the y side, you're multiplying by -1 and adding -5. All the way down. And I wrote that 1/3 as a decimal. 0.3 is not exactly the same as 1/3 because 1/3 is 0.3 repeating, but we're close enough. I just know most students prefer to work with a decimal than a fraction, and I'm okay with that. So take a minute and get your new chart. So what's that? 1 plus -3 is -2. 1 plus -2 is -1. 0, 1, and 2. Okay. So -27 minus 5 is -32, which is, again, that's too high, so we're not going to graph that. -9 minus 5 is -14. -3 minus 5 is -8. -1 minus 5 is -6. -0.3 minus 5 is -5.3. Okay, so that's what I got, but again, make sure those numbers look right to you. Is that what y'all got? Okay, I can still do math. All right, so let's draw in our horizontal asymptote. So our horizontal asymptote is at -5. Okay, so let's graph what we can fit. So I can really only fit these last three because my graph stops at -10. But if you're drawing your own graph, you could probably fit more on there. So we have 0, -8, and then I have 1, -6. And then 2 is really close to the asymptote. So this is below the asymptote. It's going to look something like that. So because A is negative, this graph is below the asymptote. So we have our horizontal asymptote at y equals -5. Your domain is all real numbers. Now your range is different. Because it's below the asymptote, this is going to be -infinity to k. Now, do you think this one is increasing or decreasing? This is kind of a trick question. When you trace it from left to right. What is my arrow doing? Going up or down? Up. So even though this is a decay graph, because it's reflected, this is an increasing function. Because you always read it going from left to right. Okay, make sure you all start on the study guide because we only have one class before we take our next quiz.